again. So you're asking this box name, right? So you take this length. $65. That's it. ఓకేనా?
సార్ డివిజన్ ఎట్లుంటుంది మరి? అంటే మధ్యలో
డివిజన్స్ అవన్నీ మీకు అలా కాదు, మీకు అవన్నీ పిక్ పెడతాను. ఇంకా యాజ్ పర్ దేర్ డైమెన్షన్స్ మీరు ఫాలో అయిపోండి. అంటే నువ్వు ప్లెయిన్ డ్రాయింగ్ షీట్ తీసుకున్నావు, రైట్?
ఎస్ సార్.
ఓకే ఓకే. నేను ఈ క్లాస్ అయిన వెంటనే ఒక పిక్ పెడతాను. దాంట్లో మనకు డివిజన్స్ అంటే సపోజ్ ఇది ఉందనుకో, ఈ డివిజన్ ఎంత ఉండాలి, ఈ డివిజన్ ఎంత ఉండాలి, ఈ డివిజన్ అలా. సో ఈ డిస్టెన్స్ మొత్తం అన్నీ ఉంటాయి. అది నేను ఒక పిక్ పెడతాను, మీరు అది చూసుకుని ఫాలో అవ్వండి. ఒకవేళ మీ షీట్లో టైటిల్ బ్లాక్ ఉంటే, ఇఫ్ దెర్ ఈస్ ఎ టైటిల్ బ్లాక్ ఇన్ యువర్ షీట్, యూ కెన్ ఫాలో ద టైటిల్ బ్లాక్. Otherwise, you can draw it. If you are using A4 sheet, no need to draw the title block. Just write the name and roll number in the top of the A4 sheet, because A4 sheet is small sheet. If you are including the title block also, we don't have any space there. Okay. So if you are using A4 sheets, don't draw the title block. Just write your name and roll number on the top of the A4 sheet. Okay. If you are using a plain sheet, whatever the title block I am giving after this class, you follow that pattern. If there is a title block in your sheet, okay, that is the third case. If there is a title block in your sheet, follow that sheet. Okay, that title block, no issue. Okay, clear?
Okay.
Okay, so we'll continue this after this class. I will send you these details. Okay, title block details. Okay, now conic sections. Okay, we will see the new topic, conic sections. This is sheet 2. Remember, this is sheet 2. Okay, so the name conic, okay, or cone. Okay, so this cone is formed.
Sir, settings change and
triangle. Settings
change and sir, remove yes sir.
Change చేశాను. Okay, settings are changed, no issue. Okay, so this cone is formed by a right angle triangle. That means this is the right angle triangle. If you sweep this right angle triangle along an axis, this is y axis and this is an x axis. Okay, if you sweep this profile, this triangular profile, okay, along y axis around 360 degrees. Okay, the solid will be formed, that is like this. So this is a cone and this is a dotted line. Okay, dotted line indicates hidden lines. Okay, here dotted line indicates hidden line. Okay, so for a cone we have a top point, this one, this is called apex. Okay, the top point is called apex. Okay, and this lower portion is called base. Okay, so for a cone, lower portion will be a circle. There is a base of the cone. We'll call it a base of the cone. Okay, and this is the yes. This is the axis of the cone. Okay, And so for a cone, we are having something like this. These are called generators. Okay, these are virtual generators. These are not available in the cone, but these are the virtual. So we'll call it as a generator. Generators. Okay. So if you see the angle of the cone here, alpha. Okay, angle of the cone is alpha. So if you take the front of a cone will be something like this. It's a triangle. Okay, so here total angle of the cone will be alpha plus alpha. It will be 2 alpha. Okay, so this is the and we call that angle is called the apex angle. Apex angle of the cone is equal to 2 alpha. Okay, so what is called generator? Generators are the imaginary lines or virtual lines. Imaginary lines or virtual lines joining the apex and the base. Apex and the base. Not the base, it's the circumference of the base. Circumference of the base. Okay, that means this circle. Circumference is a circle. So this generators will touch the circumference of the circle. So this is the cone. And if you cut this cone, in some particular angles, okay, we'll get some conical sections. Okay, conical sections. Okay, suppose this is my cone. Okay, this is my cone, and I am cutting. So this is the angle. Sorry, this is the axis of the cone. Okay, so I am cutting this cone with some angle. So this is the cutting plane. Okay, or I will write here. Cutting plane will be something. Wait a second. Okay, if I am cutting the cone with some axis, so we have learned the axis line in the first topic, line followed by a small line. So this is the cutting axis. Okay, so the cutting axis will be, ends will be somewhat, okay, like this. Okay, that means dark. Okay, the ends will be dark. So this is the cutting plane. This is a cutting plane. If we cut with some angle, okay, so we'll get something like a triangle. Okay, we'll get something like a triangle. This section is called triangular section. And this triangle will be isosceles triangle. Whatever the triangle we are getting will be isosceles triangle. That means the cutting plane, if the cutting plane is passing through apex, if the cutting plane is passing through the apex, the whatever the intersection or the curve of intersection, what you are getting is a isosceles triangle. Okay, isosceles triangle. Now same apex or same triangle, that means cone, not triangle, it's a cone. Okay, same cone. So we know apex angle is 2 alpha. So here it will be alpha only. I'm taking one portion of the angle. So we are making some angle theta. Again, I'm using the cutting plane here. That means a line, small line followed by a large line. Ends will be dark. Okay. So this cutting plane is making some angle theta with the axis of the cone. Okay, the axis of the cone. So this is the cutting plane. We'll call it as a cutting plane here. Cutting plane. So whatever the cross section we are getting is something like an ellipse. Okay, ellipse you are getting. Okay, so hatching means it's a 45 degrees line followed by 2 mm gap, like this 45 degrees line. Okay, so whatever the cross section you are getting, okay, it will go it and it is called an ellipse. This is called ellipse. Is the ellipse. Here the condition is theta should be greater than alpha. Sorry, theta should be greater than alpha. Okay, suppose alpha is 45 degrees, theta should be more than 45 degrees. So if the cutting plane is more than the apex angle, half of the apex angle, okay, so whatever we are getting is a ellipse. Okay, it should be half of the apex angle. Okay, whatever the inclination of the cutting plane should be greater than half of the apex angle. Then whatever the cutting plane we are getting is the ellipse. Okay, similarly, again I am drawing the cone front view of a cone. Okay, and this is the axis line. Okay, so this is the axis line, and if you are cutting an alpha here, this is our condition 1. Okay, this is condition 1. Now condition 2. Condition 2 is here theta is equal to alpha. Theta is equal to alpha. So here it is, the angle is half of the apex angle alpha. Okay, so same angle, we are using the same angle like this. Okay, so ends will be somewhat darker. Okay, this is the cutting plane and this is the theta. Theta is the cutting angle, or yes, cutting angle only. Okay, so here the condition is theta is equal to alpha. So here, whatever the cross section we are getting is something like this. So here the name of the cross section is parabola. Okay, here the name of the cross section is parabola. That means if we want to get a parabola, the condition is the cutting or cutting angle, whatever the cutting angle should be equal to half of the apex angle. Okay, so the condition is cutting plane or inclination of the cutting plane. You can write it as inclination of cutting plane. Is equal to half of the apex angle. Half of the apex angle. Okay, so that is theta is equal cut. Half of the apex angle. Half of the apex angle means alpha. Apex angle is 2 alpha. See here.
Okay,
Apex angle. Apex angle is alpha, 2 alpha. So half of the apex angle means we will get alpha. Theta is equal to alpha. Okay. So whatever the cross section we are getting is a parabola. Okay. So
Sorry,
that's all.
second.
Second.
మళ్ళీ ఒకసారి చెప్పండి సార్ ఫస్ట్ కాంచి.
Second. Okay. So if a cone is there, we are cutting a cone. With an angle theta. Okay. So what is theta means here? If you want to get a parabola, theta should be equal to alpha. Alpha is nothing but half of the apex angle. Theta is equal to alpha. Alpha means half of the apex angle. If you are using the same inclination as alpha, then whatever the cross section we are getting is a parabola. Clear?
Okay, sir.
Okay. So next one is we are having some another one, that is hyperbola. I think we have discussed these things in mathematical form. For every term, what I'm telling here, they are having some equations. Those equations are solved in M2, that is in intermediate mathematics. We have already solved these equations. Okay, parabola equation, hyperbola equation, ellipse equation. Okay, so now we are not going to the mathematical form, but rather than we are constructing a conical sections here in this engineering graphics. Okay, so the next one is same cone. So I'm using the same cone. Okay, I'm using the same cone, but here I'm changing the angle again. So this is the axis of the cone. This is the axis of the cone. This is the axis of the cone. And we are having some cutting plane. Here the condition is, what is the condition is? So theta, we have seen theta greater than alpha. If theta is greater than alpha, we are getting what we are getting? We are getting an ellipse. Theta is equal to alpha. Theta is equal to alpha. We are getting a parabola.
Parabola.
Next, theta is less than alpha. one more case we are missing, that is theta is less than alpha. Okay, so what is theta? Theta is the inclination of the cutting plane. Inclination of the cutting plane. Okay, so if you are using this theta is equal to alpha, what the condition we are getting, what are the cross section we are getting is the hyperbola. Okay, so that means here the cutting plane. What are the cutting plane? This. So ends will be darker, somewhat darker. So the cutting plane axis will be a line followed by a small line followed by a small line. So this is the cutting axis line. Ends are somewhat dark. Suppose if you are using the axis line followed by dot, line followed by dot, line followed by dot. This is the axis line. And this is the cutting plane line. Okay. So make sure the difference and come to the conic, and here this is the angle. What is the angle is here? This is alpha, half of the apex angle, and this is the theta. So here alpha, the condition is theta is less than alpha. Theta is less than alpha. That means the inclination of the cutting plane is less than half of the apex angle. Okay, don't confuse. Half means here we are considering only alpha. Apex angle means 2 alpha. That's why I'm calling half of the apex angle. Okay, so whatever the cross section we are getting, is something like this, and this this cross section is called hyperbola. Okay, so this is the background of the conic sections, and now we'll see the first one is construction of an ellipse. Okay, so here ellipse. Okay, so ellipse can be constructed using so many methods are there. So the first one is eccentricity method. And another name for this eccentricity method is the general method. So if you talk about the conics means, first we'll talk about the general method. That means eccentricity method. That means E. According to E, we'll discuss we'll construct the conics. Okay. So next topic is, next type is, okay, intersecting arc method. So intersecting arc method. Next one is concentric circles. Concentric circles method. Okay. Fourth one, oblong method. Oblong method. Again, in this oblong method, we have two different things. That is one rectangular method. Next one is parallelogram method. Parallelogram method. So, but you are very precise one, that is we have only one method, that is called general method. So we have only this method. So remaining methods are not there for you. So if you open any engineering drawing book or engineering graphics book, so many methods are there, but don't worry, you need not follow those methods. You have to follow only one method, that is the general method. And another name for the general method is eccentricity method. That means it depends on E. It depends on E. Okay, whether E is less than 1 or E is greater than 1 or E is equal to 1. So depending on that okay, so depending on this, we'll decide what is the conic section we are getting. Okay, so we have only general method, that is the eccentric method. Okay, so while drawing this eccentric method, we have few things to remember. That means an ellipse is defined. That means if you define an ellipse, okay, so in eccentric method, okay, especially in eccentric method. So in this method, an ellipse can be defined as a locus of a point P moving in a plane such a way that the ratio of the distance from the fixed point to the fixed straight line is constant. Okay, and is always less than 1. And it is always less than 1. Okay, so I will tell you what is this definition. Okay, so here E is less than 1. If E is less than 1, then we'll call it as an ellipse. Okay, so we have an ellipse. Yes. Okay, so for this ellipse, we have yes. So this DD is called directrix. So this DD line is called directrix, or I will write here. So this DD, what is DD means? Directrix, DI or is directrix line or directrix. We'll simply call it as a directrix. Okay, so we have two lines, that is AB. This is A, this is B. Okay, and AB. EF. This is one more line, EF. Okay, and V1. This is V2. Here V1, V2 is the major axis. Okay, EF is the minor axis. We all know minor axis. Okay, and AB is the principal axis. AB is the principal axis, and DD is the directrix. Okay, DD is the directrix, or I'll write here. Okay, and what more we are having? Yes, focus. So here it will be one F1. This is F2. Okay, F1, F2. That means M, P. So here F1, F1, F2. What is this F1, F2 or the foci or focal? Okay, and V1, V2 are the vertices. Major axis, or you can write it as vertices. vertices. Okay, so these are the terms or the terminology we'll use to define. Okay, so that means wherever you move this P, MP by F1P, if you take the ratio, okay, it will be always less than 1. That is the eccentricity E. Okay, we'll call it as E. Okay, and E should be less than 1. And how you have to draw this one? Okay, we'll follow. If you see the definition of an eccentricity E, that is defined by small e. Eccentricity is nothing but Pf1 divided by Pm. See here, Pf1, that means this line divided by Pm. So if you take this ratio should be less than 1 for ellipse. Okay, so this ratio should be less than 1 for ellipse. If it is equal to 1, it is parabola, and if it is greater than 1, it is hyperbola. Okay, that's how we'll define conics using a eccentricity method. That is the general method. Okay, any doubt till now? Okay, so how we'll define a eccentricity E? It is the ratio of distance of the point from focus to the distance of the point from the directrix. Distance of the point from the focus means F1P to the distance of the point from directrix, that means MP or PM. Okay, so that is the definition of an eccentricity. And how we will draw this ellipse, I will tell you. I think this thing we'll discuss in the next class. I think almost 5:50 is over. So wait a second, I will take the attendance. So please be punctual to the class. Some of your friends are coming very late. That's why I'm not allowing them to the class. I'm not admitting them. So come to the class, be on time, because again you have to attend the another class also. Okay, so right now we'll stop this class. Okay, tomorrow we'll start how to draw this ellipse graphically. Okay, so how to draw this ellipse. So that's all for today. So if you are having any doubts, you can ask me.